Hello and welcome to Keep Coding. So, from this video, we're going to start a new series of videos. It is about data structures and possibly if you have some algorithms in Golang. Okay, so most of the time we're going to use generics because now we have generics finally in Go. And then we're going to start this video with Stack. So, if you don't want to miss the future videos, please subscribe to the channel. So, now we're going to look into Stack. So, Stack is the simplest of the data structures. So it is nothing but a container. Imagine a box or a cylinder which is having an opening at the top. Okay, so that you'll be able to add items at the top of the box or the container, so that it'll go down into the container and then you'll be able to add more items to it, just like this. Okay, so you call it pushing. So you add a data by pushing to that container and it goes to the bottom, and then you'll be able to add more items to the container just by pushing on top of one another. Okay, and what happens when you want to fetch the data back? You'll not be able to fetch the data from the bottom or in any order you want. You'll be able to take the item only at the top of the container, just like a physical box or a cylinder. Okay, that would be the case in a physical box, right? And you won't have any idea about the data that is residing below the top item, so you'll be able to see only the data at the top. Okay, so at any point of time you can just come to the container and see from the top and see which item is there at the topmost level. Okay, and we call this operation as peek. Okay, and then if you want to take the item out, then we call this operation as pop. So you take the item at the top and then only you will be able to peek into the item below it or pop the item below it. Okay, so we have only these three operations in a stack. You can push an item, you can pop an item, and then you can peek and see which item is there at the top. There are many ways to implement it. You can use an array, you can use a slice, and in our examples we're going to use a linked list. Okay, so that is the most sophisticated way of implementing stack, and as well as we'll be using generics going forward in all the data structures. Wherever possible, we'll be using generics as well. Why would we need a stack in the first place? We need stack for a lot of operations, like the compiler uses stack and the parser uses stack. So in the case of HTML, so you have a tree structure, right? So you have the root element and then a body and then divs. So the parser has to go through each item and then it should be able to add it into a stack, and then whenever a closing tag is coming, then it will be popping it out. Okay, so this way it will be able to always match the opening item and closing item, as in the case of HTML. So when you have an opening div, then you'll be having a closing div as well, right? So you have to match all this and then you have to verify if the document is correct. So in these cases, stack is the most appropriate data structure. Okay, so enough talking, let's jump into the code. So now here I have a freshly created package. So I just did a go mod in it and then created this module. So now here I'm going to use create main.go. It's going to be package main and then a main function. Okay, now I'm going to create one more package under this. I'm going to call this stack. Okay, so here I'm going to create a new file named stack.go. Okay, so for each data structure that we are going to create in future videos, I'm planning to add them as a separate package within this, and then in the main file I'll use them and show how to use. So the reason I'm creating a package is that I'll be having private types, private functions, which I don't want to be accessed from the main.go, right? So that's the reason I'm having this example of showing you how to use packages to design this. So here, so obviously I'll need a type which is going to be named stack, and then it will be a struct. Okay, so each stack, as I showed you, will have a pointer to the topmost item. It will know only the topmost item, and the topmost item is going to connect it to the next item below it. So these kind of linking using pointers is what we call linked list. Okay, so each item will have a link to the next item. So in a stack, you technically need only the reference to the topmost item. So here I'm gonna need a pointer to the topmost item. Okay, so this top is going to be of what type? So we don't know the type, right? So it is going to be using generics. So here I have to give the generic type t, and it can be any type. So I'm giving the constraint as any. Okay, so you can push an integer, a string, or another structure or pointer, whatever you want, you'll be able to. Now though we are using generics here, so I was telling you, right? So in a linked list, each item will be having a pointer to the next item. Okay, so here we don't have a pointer to the next item, we only have the pointer to the topmost item. So obviously what we'll need is that we need to define a type for each item, so that each item will be containing the actual value as well as the pointer to the next item. Okay, so I'm going to create a private type here. That's why I'm using a smaller case I for the item. So and then I'm going to say any type. So now this will be having a value of type t as well as a next of type item. Okay, and this item will be having the type t. So okay, it's a pointer. Okay, so I have to give a star here. Yeah, so that's it. So we have to use this item here. So the top pointer will be pointing to an item of type t. Okay, so now we have three operations. One, we have a push where we have to add the item, and then we have a pop where we'll be removing the item, and then we have a peek where we'll be just seeing the item, and we won't be actually popping it out, but we'll be just checking what is the item on the top of the stack. So let's define the push operation now. Okay, so I need to add a function named push, and then it will be taking a value of type t. Okay, so now I cannot take t and directly add it to the stack, so I need an item wrapped around it, so only then I'll be able to add to it. Okay, so I'm gonna say new item is equal item, and then the item's value should be val, and then it will be having a pointer, right? Next pointer. So the newly created items next will be the current top. Okay, so I'm giving s dot top. Yeah, I have to create, I have to give the type here. So whichever type is gonna come from the generics, I'm passing the same type to the item that I'm going to create. Okay, so now s dot top is going to point to the newly created item. Okay, so that's all we need to push an item. So we are not going to return anything. You add something to the top of the stack and it's not an issue. Okay, so now I'm going to peek into a stack and get the value at the topmost. Okay, so let's see how does a peek look. So peek doesn't take any parameter, but it will return a type of t when the stack is having some value, and if the stack is empty, I cannot return anything, right? So in that case I want to return a bool, and this bool will be true whenever the stack is actually having some value, and it will return the value, and this bool will be false when the stack is not having any value. So I'm trying to keep this API similar to the map API that we are having in Go by default. So in the map you'll be able to read an item and use this boolean variable next to it as a tuple assignment, and then you'll be able to say whether reading the value from the map is a successful operation or not. Okay, so similarly I'm adding a bool so that I'll be returning a false whenever this stack is empty. Okay, so it means if s dot top equals nil, okay, return, I need to return a default value, right? So for that what I'm going to do is that var val of type t, and then I'm returning val comma false. Okay, so this will return a default value which we are going to discard, because whenever we are receiving a false, we'll consider that as a failure operation. Okay, the stack does not have anything, so we're not going to do anything with the value. But then since we have to send two values to the tuple, and I'm not using a pointer here, so that's why I'm returning a default value like this. Okay, so otherwise what we're going to return is that return s dot top dot val comma true. Okay, that's it. So now you are returning the value at the top without doing any change to the stack. So you'll be returning it true as well, so that you are actually having at least one value at the top of the stack. Okay, so now you have one more operation, pop, which is gonna just pop out the value at the topmost level. Okay, so I'm creating one more function. Okay, so it's going to be pop, and again it is not going to have any parameters, and it is going to have the similar return type. Okay, so val t if s dot top is nil, then I'm going to return val comma false. Okay, so if the stack is not having anything, I don't have anything to pop, right? So I'll just return a false, and otherwise then now I have to pop. Okay, so what I'm going to do is that val equals s dot top dot val, and then s dot top equals s dot top dot next. Okay, now now top will start pointing to the next item in the stack, and then the previous item will be left without any pointer, which means the garbage collector will remove the item from the memory automatically. Okay, so now I'm going to say return val comma true. Okay, so that's it. Now let's go to the main file. Okay, so here I'm going to create a new stack. Okay, stack dot stack. Okay, so here I need to import the package. So import github.com/ then add a var. Okay, sorry, directly I will create a stack using assignment. Okay, so now I have created a stack, and then I can add items to the stack. Okay, so this stack should be having methods like push 25. So if you see this, I have missed to give the generic parameter, which I need to specify if it is going to take which type, right? So I'm passing an int, so that I'll be able to push int to this stack. Okay, so in case if I changed it to string, then I'll not be able to add an integer value to it. Okay, so if you see, the type of the function itself will show string. Okay, so here I'm going to use int for now, and then I'm pushing these values, and then we're going to see what is the topmost value. Okay, so we cannot pick directly like this because we are returning two values. So I'm going to say if x comma ok equals s dot peak, and then if ok is true, which means we have a value, then print the value. Okay, otherwise we're going to say ln no items found. Okay, so now let's run this. Okay, go run main.go. See, 75 is the item that we pushed at the last, okay, and the peak is showing, 75 to us, okay. So now what I'm going to do is that I'm going to, instead of peaking, I'm going to pop values one by one, okay. So what I'm going to do is that I'm going to have an infinite loop, and I'm going to pop those values one by one. It is having the same signature, so I don't have to change anything else, but here I have to print no items found and then break the loop, okay. So now the expectation is it will show 75 first and then 50 next and then 25 next, because we have pushed it in this order, okay. Now let's run this, okay. See, 75, 50 and 25, okay. So these are the operations that a stack normally does. So now since it's generic, I'll be able to use something like this, okay, and then I'll be able to create a record of a stack of records. So here I can give record of a comma 20 b comma 25. So let's have two items for now, and then I'm just going to implement a stringer, sorry, I need to use an R here. So I'm doing this so that you'll be able to see something useful here when we are passing this values to println, okay. It will call the string function and get the value and show. So now I go back and run. See, I pushed a first and then b second. So it's simple as that. So now if I need to have a stack of pointer of records, then I'll be able to put a star here. So immediately if you see, it is showing us error, so I'll not be able to pass a value. Instead I have to give an address operator like this, okay. See the same result. So that's it about stack. In the upcoming videos we'll see queue, linked list, and then other data structures like trees and binary trees and all. Please subscribe to the channel if you don't want to miss it. Thanks for watching. Bye.